8.2 notes. We're going to be working on 8.2 notes today, law of sines. So law of sines is used when we do not have a right triangle. So law of sines is used when we have different types of triangles without the 90 degrees. SOHCAHTOA is reserved for right triangles, and then we can use law of sines for the rest of them. The law of sines is a three-part formula. We are only ever going to use two of the letters at the same time. So maybe you are working with A's and B's, or likewise you could be working with B's and C's. And it also works if you are working with the A's equal to the C's. So it's really three formulas in one. So first we start by labeling the triangle. And the thing about the labeling the triangle is they are not O, A, and H anymore. We have matching letters, which most often of the time is A, B, and C. But regardless, matching letters are across from each other. The capital letters tend to be your angles, and the lowercase letters are your sides. So A, B, and C are your angles, and little a, B, and C are your sides. All right, so let's take a look at example number 1. We're going to start by labeling what we have as the numbers across from each other. So notice you have capital A and lowercase a, one across from the other. I have lowercase b, which means this must be capital B, angle B. And since I've got the A's and the B's, that must be this other side is lowercase c and capital C. And then what I like to do is create a chart. It helps me keep things organized. So I'm just going to do A equals and then little a equals. And I'm going to set this up so it looks very similar to my formulas. And then we're going to put in the numbers that we know. Let's see, I know angle B is 45 degrees. Angle C is 95 degrees. And side C is 5. So the first thing we're going to do is find angle A. And I can do that pretty easily because I know all the angles of a triangle add to 180. We learned that back in geometry. So what I can do is I can take 180 minus the two sides that I know, type that into a calculator, and we get 40 degrees. So then I can fill this in as 40 degrees. Then it's up to you. You can either find side A or side B. It really doesn't matter. I'm going to focus on first finding side A, little a. And we're going to have to set that up using the A's and the C's. If we try to use the A's and the B's, I'm missing two numbers, one A and one B, so I can't set that up. So I have to make sure I use the C's because I know the 95 and the 5. So it goes like this. The sine of 40 degrees over side A equals the sine of 95 degrees over 5. We'll cross multiply and divide. So A times the sine of 95 equals 5 times the sine of 40. And then you'll divide both sides by the sine of 95. When it's time to type it into your calculator, make sure you're in degree mode. So again, go to your mode right here. Make sure it's set for degree mode. If not, toggle down, change it over, hit enter. So I'll type in 5 sine of 40 divided by the sine of 95. Closing the parenthesis, noticing on each I close the parenthesis, and then hit enter. It does ask us to round to the nearest 10th place, so we're going to call that 3.2. And then you can put that in our chart, 3.2. That was very sloppy. I'm going to rewrite that. 3.2. Okay, that's a little better. All right, and now it's our job to find side B. I'm going to do that by using the B's as well as the C's. I like to avoid the decimals when I can. So I'm going to use the C's because I know both of those answers were given to me. Sine of 45 over B equals the sine of 95 over 5. Now I want to show you a little bit of a shortcut so that you don't have to write out all of this step every time. Watch what we did. We ended up typing into our calculator 5 multiplied by the sine of 40 and then divided by the sine of 95. So we multiplied that and divided that. So into your calculator, if you're able to see that cross multiplication and division, you can type it in as 5 multiplied by the sine of 45 and then divided by the sine of 95. So you would cross multiply and then divide. Saves a little bit of writing. If you don't love that, no worries. You can write the whole thing out. That's fine. Oops. All right. So we get an answer of, let's see, I think that rounded to 3.5. Yep, 3.54, which would keep us at 3.5. All right. And right at the beginning of that problem, I kind of skipped this step, but when it says solve the triangle, that means that you need to find every angle and every side. Find all angles and all sides. Not every problem will ask you to solve the triangle. Sometimes they just ask you for one particular side. So just make sure that you're watching carefully on what the directions say. For example 2, the good thing here is we don't need to draw a triangle. We can actually do this problem just based on our chart. So this one has D, E, and F. So we'll set it up like that. Again, mimicking the law of sine. So D is representing your A's, E is your B's, and F is your C. So A, B, C, D, E, F. All right, let's put in the numbers we know. Side D is 24 centimeters. Angle, remember that means angle E, is 152 degrees. And angle F is 8 degrees. Notice they don't say solve the triangle. We don't have to get every side, every angle. All it's asking for is the length of side E. So all I'm looking for is that answer. So as soon as I can find that answer, I can stop working on that problem. All right, first thing we're going to do, find angle D. All sides of the triangle add to 180. So 180 minus 152 minus 8. When you type that into your calculator, you get 20 degrees. So that goes in for D. So it's important that we get two of the same letters here in order to be able to then solve for a missing side or a missing angle. So now that I have both of these, side D and angle D, I can use that to help me find side E. I set it up as the sine of 20 over 24 equals the sine of 152 over E. You would cross multiply and solve it all the way out. If you're more comfortable writing it out, go ahead and do that. If you feel okay just typing it into your calculator, it would be 24 multiplied by the sine of 152 divided by the sine of 20. (24) times the sine of 152 divided by the sine of 20. Close the parenthesis after each one. And this one tells us to round to the nearest tenths place. So for an answer, I'm going to get 32.9 degrees. 32.9 degrees. Sorry, not degrees. 32.9 is my side. Technically centimeters. Now, you do not have to find side F because it is just asking for E. So you can actually stop working a little bit early on that one. All right, for example, number 3, we have different letters now, V, W, and X. Again, you want to set it up the same way we have before. Take a second and see if you can put all the numbers in the right spot. All right, you should have the 182 for one of the sides. 21 degrees is your angle V. 136 is your angle W. And what are we looking for? We are looking for the X. So that's all we're going to have to solve for. Unfortunately, to solve for that X, we're going to need to get the angle X first. So first step, find angle X. To do that, we do 180 minus the angles that we already know. That subtracts to get us 23 degrees. So we can put that right there. And then let's find our side X next. Remember, we don't even have to find this V, so don't worry about that. Let's focus our attention on the X. We're going to use our W's to help us because notice we have both of the W's. So find X by doing the sine of 136 over 182. Notice how nicely they set up one on top of the other. Equals the sine of 23 degrees over X. Remember, you can cross multiply those and then divide if you choose. If you don't like that method, you would write out X times the sine of 136 equals 182 times the sine of 23. And you divide by the sine of 136. Notice how you're getting 182 times the sine of 23 divided by 136. The same thing we had over here. 182 times the sine of 23 divided by the sine of 136. So same exact process, just saves you a little bit of time as far as writing. We'll type that into our calculator. 182 sine of 23 divided by the sine of 136. Notice we are still in degree mode. And close parentheses after each one. Round to the nearest tenth of a centimeter. That'll be 1 decimal place, which looks like 102.4. 102.4. And it looks like we're talking about centimeters. And again, you would not have to go back and find that side V. As long as you find what they're asking for, you're done with the problem. All right, for the next one, example number 4. Notice the directions here are asking us to solve the triangle. So this would be a really good time to pause the video, try this problem on your own, see how much of it you can do and where you get stuck, and then unpause it and you can go through the whole thing. Fill in the information you know. Solve the triangle means we need to find all of them. We'll start with U. Angle U, 180 minus 73 minus 71 gives me 36. Then let's focus on either S or T. It doesn't matter. Let's find side T next. So I can't use S's to help me find T's because I'm missing both of those. I'm missing S and T. So I need to find my U's. Have my U's help me out. I've got sine of 71 over T equals the sine of 36 over 40. So I'm literally taking that, which is right here, and then that, which is right there. Okay, let's cross multiply and divide. So 40 multiplied by the sine of 71 divided by the sine of 36. Still in degree mode. It's going to get me 64.3 when I round it to the nearest tenths place. 64.3 for T. And then letter S. For letter S, I still go back and use the U's because they're a little bit easier to work with without the decimal. So sine of 73 over S equals the sine of 36 over 40. Again, using these numbers and these numbers. Cross multiply and divide. It's almost the exact same problem. The only difference is in the green I had 71 and in the blue I had 73. So I expect to get a very similar answer. 40 sine of 73 divided by the sine of 70. Sorry, divided by the sine of 36. There we go. 65.1. Let's round that up. 65.1. And again, when it says solve the triangle, it means at the end you want every single number, sides, and angles accounted for. All right. I want to do one more problem with you. We've got a story problem here. And again, the best thing to do is draw a picture. So we've got Alexis, Brianna, and Carmen. Notice I'm using A's, B's, and C's here to help us out. So I've got Alexis, right there. Brianna right here. And Carmen over here. They're throwing a Frisbee around the backyard. There's 3 of them, which means they're making some sort of a triangle shape for this problem. Now we're going to trace where the ball is going. Alexis throws the Frisbee to Brianna. When Brianna catches the Frisbee, so now Brianna has it, she's going to turn 50 degrees and throw it 12 feet to Carmen. So she takes the Frisbee right here. She turns 50 degrees and she throws it 12 feet. So 12 feet, a distance, will be the side, and 50 degrees will obviously be the angle. Then Carmen catches the Frisbee. So now the Frisbee's right here. She turns 60 degrees and throws it over to Alexis. The question is, how far did Carmen, right here, throw the Frisbee to Alexis? We're looking for that side right there. So what I would recommend is setting up the same chart that we were using before. Angle B is 50 degrees. Angle C is 60 degrees. And this 12 must be side A because notice it's directly across from the A. All right. All we're looking for is this X right here, which notice it's directly across from angle B, which means that's going to be side B. So all we're looking for is this one right here. Right. We'll need to first start by finding A. 180 minus the angles that we already know. That's going to get us 70 degrees. And then let's find side B. Same setup as before. We're going to do the sine of 70 over 12 equals the sine of 50 over lowercase b. We'll cross multiply and divide. So always cross on the ones that you know. So if you're typing this straight into your calculator, you would do the number multiplied by the sign. You don't want to do b times sine of 70. B times sine of 70 you can't type into a calculator. So 12 times the sine of 50 divided by the sine of 70. Again, reminder, you're in degree mode. 12 times the sine of sine of 50 divided by the sine of 70. Close parentheses on each. Hit enter. And on this story problem, make sure that's a reasonable answer. Is it reasonable if someone threw a Frisbee approximately 10 feet to somebody? Yeah, you can throw a Frisbee 10 feet. If you get something absurd like 2,000 feet, you can't throw a Frisbee that far. So you just got to be careful in your story problems that your answer is reasonable. So for side B, it also doesn't tell us how to round. Let's just go to 9.8. And I believe we are in feet. There we go.